Hello everyone and warm welcome to this session. In this video, I'm going to demonstrate you how we can perform image division in the MATLAB environment. So for writing a script, we need the editor window. So I maximize the editor window. We start with coding with the syntaxes of MATLAB, that is close all, clear and CLC. We add one comment line to mention what is the motive behind writing this particular MATLAB script. So I write this is a program to demonstrate the image division. So for accomplishment of image division, first of all we need the two images available in our MATLAB environment that we need to access from the current folder or current directory. So our first module, it will be to read the input images. So here I'm going to generate the first variable as capital A with the help of imread command followed by a pair of parentheses, where inside a pair of single quote I need to provide the name of image file, that is cameraman.tif. So TIF is the file extension that is also needed. So this is supposed to have the first image. We require second image also, which will be dividing the first image. So the second image we are going to generate synthetically. So that is not a ready-made data set that we are going to access from the current directory, but we can generate it synthetically in this script. So here I will be generating a variable capital B that will be with the help of a matrix of zeros. So initially I will have a matrix of zeros, so it will be having a particular order. So we keep the same size as we are having for variable A. So this is possible with size A here. Now there it will be a matrix. Suppose we are having small m and small n to be the two dimensions of the first image stored into the variable A. So for the same size, there it will be a matrix m rows and n columns and all element values equal to 0 here. Now let us say, for example, I add it to 0.5, because if you have it the matrix of zeros and visualize it as image, it will be a complete dark here. So I just select intermediate gray shade between a complete dark and complete white here. So what we can do here, we will assign a range of few pixels. Let us say, for example, I select 51 to 150 for the first dimension. For the second dimension also I may go for 51 to 150. So these many pixels will be assigned logic level equal to 1 here. So they will be complete white if you have visualization of such an image here. So now after having the two images ready, now we can proceed to perform the image division. So this is our main and the next module here, so image division. So for division of the image, we will be getting certain result that we are supposed to store into variable capital C. So as we are having the image A from the ready data set cameraman.tif and image B we are generating synthetically in this particular script, so they are having different data types here. The cameraman.tif is generally into the uint8 type that I will make you visualize in the workspace, whereas the image B will be of the double type as it has been mathematically generated by the help of certain MATLAB syntaxes working on the matrices here. So here what we can do, we have to first of all match the two data types here. So I will make the image A of the data type double here, and then further I will have division of it from the second image stored into the variable B. So here we will be having the dot forward slash here, and further we will be writing capital B here. So this is element wise division here. So now after performing the image division, the last module is to have display of the input and output images. So I will write display of input and output images, for which I'm going to make the use of subplot here. So I will be generating 1 row, 3 columns, and then to the first cell I'm going to have the display with the help of IAMShow command, where the input argument I am providing as capital A and the corresponding title as it is our first image. So I will give it a name image 1. So by the next line I will go for display at the next cell. So it will be 1, 3, 2. Again the use of IAMShow command. The input argument this time it will be capital B, and the title here I write this is image 2, and at last I will go for accessing the last cell of subplot. So 1, 3, 3, the use of IAMShow. Now as we are going to display the result of this division, and as we are getting it into the double type for proper display of such image or visualization, we need to get it back in the uint8 environment here, and then the input argument will be C here, and then we can provide the corresponding title that this is the result of image division. So this is all about our simple script to demonstrate the image division. I will save the script. So let us say, for example, I give it a name program underscore 27.m will be the file extension. So we have saved it. Let us check. Yes, the file has been generated into the current folder. The name has appeared on the editor tab. Now as you see, the workspace is currently empty. We execute this program by just pressing this run button. Now you see in the workspace there are 3 variables generated. The first variable capital A with the dimensions 256 by 256, data type uint8. So this is as it is the line accessing the cameraman.tif from the current folder here, whereas the variable B is there with the same dimensions but the data type double here, as we have formulated it here synthetically we have generated. And after performing the division, A image is divided by B image, the result is stored into the C. The dimension of the pixel values are same here 256 by 256, and the data type is double, and finally they are displayed with the help of subplot here. So I maximize the window that is having this subplot. So this is our image 1. Okay, so this is cameraman.tif original image dataset. This is synthetically generated another image that we have denoted by variable B here. Now after we divide image 1 by image 2, this is what the result of division here. So as you can see, this is what gray shade, that is having 0.5 value. So this is exactly the center between complete white and complete dark here. So if this complete white portion is there, so it is larger value than this, that means it is 1. So when you have division of this much of range by 1, it won't be affected. Any value divided by 1 won't be affected, and when a certain value is divided by a number that is less than 1, so the resultant is larger than the original value that it was divided here. So that is why a lot of brightness you see into the range despite the location that we have specified in our programming, 51 to 150 row wise, and again 51 to 150 column wise here. So this is what the simple demonstration we have tested on cameraman.tif. So one thing should be clear to your mind: whenever you are applying the arithmetic operations to be operated on the imaging datasets here, so the two operands should be of the same dimensions. Otherwise, if you are having a division by a scalar, that is always allowed here. So that particular scalar will be dividing each and every pixel or the element into the matrix representation here. So I just complete this demonstration of image division. Thank you.